Hello, this is Dr. Russ with an example of a correlation problem. We're calculating the Pearson R value for a linear relationship. So here's the problem. Using alpha equals 0.05, test the hypothesis that there is a positive relationship between the number of very close friends an older person has and their physical health. And you can see the data are here. Person 1 has 2 very close friends and their health is 10. Person 2 has 4 very close friends, their health is 22. Person 3 doesn't have any very close friends left and their health is 8. And you can see the same data for persons 4, 5, and 6. So we'll start with the 5 steps of hypothesis testing. So as we begin with step 1, population 1 and population 2 are going to be kind of different for correlations. We can see that we are having people like those in our sample. Let me get my keyboard better positioned here. And we're comparing them to people with no relationship between the variables. What variables are we measuring? Well, variable X is the number of close friends, very close friends, an older person has. And variable Y is health. The direction of the hypothesis is stated in the problem. In this case, it's stated directly. It's positive, which means it would be a one-tailed high test, or it could be negative, which would be a one-tailed low test, or it could just be a relationship without a direction stated, in which case it would be a two-tailed test. And you would want to also check the data to see if there's a prediction that is stated but doesn't use the words positive or negative. And in that case, you'd look to see if they're predicting that as friends increase, health would increase, which would be positive, or that as friends increase, health would decrease, which would be negative. So you'll have to look into the problem to find the direction. In this case, the word positive indicates one-tailed high. And so the research hypothesis is there will be a positive relationship between the number of very close, let's just say between variable X and variable Y. And the null hypothesis is just the opposite of that statement. There will not be a positive relationship between variable X and variable Y. You'll have seen in class the other shortcuts we can use for stating hypotheses, and you're welcome to use those too if you're comfortable. So our next instruction is to create a scatter plot and estimate the R value by looking at the scatter plot. So we're going to draw that out and look for direction and strength. And I'm going to do the scatter plot right up here by the data so that I can do it well. So we're going to have an x-axis and a y-axis that are fairly equal. I'll draw them like that. That seems pretty decent to me. We'll write our friends here. And we'll write health here. The number of friends ranges from 0 to 4. So I'll start with the 0 down here. I'll put the 4 up here and divide evenly to mark our data points. 1, 2, 3, 4. And the next variable is health, which ranges from 8 up to 36. And I think that what I'm going to do is plot these in 4s once I plot this 8. So I'll put the 36 up here, and I'm going to go up to 12 kind of close here. And from there, I'm going to be able to plot these a little bit more evenly since it's sort of an odd number of items here. So we'll go from 12 up to 16 to 20, 24, 28, 32, and 36. So that's a nice even distribution. So our first person has 2 friends and a health of 10. So here's the 2, and the 10 is pretty low, way down about here. Our next person has 4 and 22, 4 friends, and 22 on the health scale will be right about here. 0 and 8 for our next person will be right around here. 3 and 36, 3 and all the way up to the 36. 2 and 27. That's going to be, I'm following the 2 up, and the 27 will be right about here. And 1 and 23. Here's the 1, and we'll go up to where the 23 would be right about there. And, well, I can't see too much from this, but I can see that it looks like we're going in a generally positive direction. So I'll draw the line of best fit going this way, and that line is just the line that's closest to the greatest number of points. I think this is pretty close to the points as well as I can estimate. And so now we're going to determine the direction. Is it positive or negative? And I see it's going in an upward direction, so it's positive. And the strength, that'll be a number between 0 and 1. And the closer the points are to the line, the higher that number will be. So looking at these sorts of distances, and I don't think they're all that close to the line. I think that this is maybe a middling kind of a moderate hypothesis at most. I would estimate the strength in that moderate range of 0.05. So I would write down here then that the R that I'm estimating is approximately I said 0.05 because I'm used to writing alpha. Don't make that mistake. If there's a 0 there, that's a really poor, weak relationship. It's a 0 correlation. What I'm actually predicting is 0.5. And you might make that mistake too. So do always a second look at that when you write those. And so I'm estimating that this is going to be a 0.5. I could put the plus sign or not. And let's write this down in the problem. Our estimate, this is what this looks like. I know it's really little. Our estimate is approximately 0.5. Next, we calculate the Pearson R value, and we'll go down to do all of our math here then. And so here are our data, and you can see what I did earlier before I started to solve the problem is I put all these data down here because I knew we'd need a lot of room to do our calculations. And the next thing I'm going to do is copy out the second column here and just move them over to here somewhere because I know I'm going to have to do calculations. See if I get those lined up. I'm going to have to do calculations for both. Let me move it in a little bit nearer. I created this table all ahead of time. It's in the template as well. I'm not going to use it in Word. All I needed was to divide these 2 columns. So the first thing we do is we have to calculate our z-scores for each of the 2 variables. And you'll recall that z, the formula for z is the deviation, x minus m, divided by the standard deviation. And that's our original formula way back in chapter 4. So let's go ahead and get the key information here. First, we're going to get n. And then we're going to have to calculate our mean. And to get our standard deviation, we'll need sum of squares. We'll need variance. We're not estimating this time, we're calculating the exact number. And we'll need standard deviation. So we're using these terms because we're not estimating anything, no degrees of freedom in this step. So in this case, n equals 6. M is the sum of all the scores divided by n. And if we do the math on that, we find that the sum of all these scores, 2 plus 4 plus 3 plus 2 plus 1, is 12. divided by 6 equals 2. And so that's our mean. For the sum of squares, we know we have to get the sum of all the squared deviations. And so let's go ahead and get our deviations. So our deviations, draw a line here. And so 2 minus 2 is 0. 4 minus 2 is 2. 0 minus 2 is negative 2. 3 minus 2 is 1. 2 minus 2 is 0. And 1 minus 2 is negative 1. We square all these up, we're going to get 0. So we know we have to square these deviations. And so let's go ahead and get, I'm going to draw a line here too, just for the sake of clarity. So 0 squared is 0. 2 squared is 4. Negative 2 squared is 4. 1 squared is 1. 0 squared is 0. Negative 1 squared is 1. And we sum all these up to get the sum of squares. And we discover that that equals 10. We know that our variance using the standard formula is just sum of squares divided by n equals 10 divided by 6, which equals 1.6667. And our standard deviation is the square root of our variance, which equals 1.290994. Let's stop there for the moment, and we're going to find our z-scores after we do the basic calculations for this second variable. And I'm going to move this formula here to, let's see, way up to the top of the page, I think. There we go. All right, so next we figure out our information for this side. N equals 6 again. M equals the sum of all our scores divided by n, which equals 126 when I add all these up, divided by 6, which equals 21. For our sum of squares, we have to do those calculations. So let's go ahead and get our deviations. You already know that it's just x minus m. And so 10 minus 21 is negative 11. 22 minus 21 is 1. 8 minus 21 is negative 13. 36 minus 21 is 15. 27 minus 21 is 6. And 23 minus 21 is 2. And of course, if we add all these up, they're 0. So we square them. And in this case, negative 11 squared is 121. 1 squared is 1. Negative 13 squared is 169. 15 squared is 225. 6 squared is 36. And 2 squared is 4. If we sum all of these up, we get our sum of squares, and that equals a total of 556. You can see I'm not rewriting the formula because I already wrote them here, but we can do one thing to help make things clear. We can put these little x's and y's here, the variance for x, the standard deviation for x, the mean for y, the sum of squares for y. The variance for y is 556 divided by 6, which equals 92.6667. And the standard deviation for y is the square root of the variance, which equals 9.626353. 6266353. All right, And now we're ready for this formula. So here we're going to calculate the z-score for x. So I'm going to write zx, and it's going to equal the deviation, which we've already calculated here, divided by the standard deviation. And so for this very first one, we will be doing 0 divided by 1.290994, and we're going to get 0. For this one, we're going to be doing 4 divided by 1.29, etc. And that brings us to 1.54. I don't have quite enough room to write it, so I'm going to erase that formula and just write the answer. But you can see what I'm doing. I'm just calculating the z-score. Since we've already done the deviation, it's pretty straightforward here. We're just dividing the number in this column. Let me mark it in red. The number in this column divided by standard deviation. So I have the answers here already. 1.549193. I'll put 4 digits down. 5492. I rounded there. 4 divided by that number should be the very same thing. So let me check. I have something a little messy here. Okay. Let me just double check my formula here. Okay. Yep, we're doing just fine. Negative, it's not 4, it's actually this 2 divided by, I always make mistakes, I try not to. So we're dividing this -2 by the standard deviation to get the negative 1.5492. 1 divided by 1.290994 is 0.7746. 0 again is going to be 0, and 1 is again going to be minus, -1 is going to be minus 0.7746. So these are the z-scores for each of these individuals in terms of their number of friends. We next calculate zy using the same formula. Once again, let's remind ourselves, I think I'm going to highlight this column right here, so that I don't accidentally use this column. In fact, since we're done with it, I'm going to cross this column off to remind me to use this column and actually subtract -11 divided by this. Let me look at that number again. Here's the decimal point, 9.626353. 9.626353. And so that's the formula. Now I'm going to take it away so that I have room to write here. That's what we're just doing. And we're going to get for this very first one, -1.1427, -1.1427. For the next one, we get 0.1039 rounding. For the next one, we get -1.350405 if I round. For the next one, we get 1.5582. And for the next one, 0.6233 rounding, and finally 0.2078 rounding. And now we are finally just about done. Next, we have to get our cross products, which is just, I'll make this column in a different color so that we're clear that this is based on data from both the variables. And so we're going to get zx times zy. These are called our cross products. And so we're multiplying zx times zy for each individual. And zx, zy for our first person, because we're multiplying by 0, is 0. Our second person is 0.160933. I might as well write the whole thing there. Our next person is 2.092123. I'm using Excel, so if you are doing this by hand using only 4 digits, your numbers will differ slightly, but not a ton. 206,994. Next, we have this 0 times this number, and we get 0 whenever we multiply. And we have this number times this number, and we get minus 0.16093. We add all these together to get our sum of cross products, and that equals 3.29917. And we figure out our R value, our R score, by taking dividing by n, taking the average of all of those cross products, and that's our R score. And when we do that division, we get 0.549853, which will round to 0.55. So now we're ready to write that into our formula. We can write R sample equals 0.55. Our guess wasn't too far off. You know, if you're seeing something that's really different, you might want to question yourself. So next we find our cutoff point. We have alpha 0.05 stated in the problem. DF in a Pearson test is the number of individuals. So in this case, we only have 6 people, but we subtract 2 because we have to subtract 1 for each of the 2 means we calculated. We calculated 2 means, so 2 columns of data. So 6 individuals minus 2 means is 4. So that's our degrees of freedom. And we already said we were doing one-tailed high. So let's go ahead and use our calculator tool. So here is our tool. You can find this on your left menu. Our degrees of freedom were 4. Our significance level was 0.05. We can calculate. And we accidentally made a mistake. This is the mistake I just made. In this particular calculator, you want to find the correct tool. And in this case, it's the R value that we're looking for. And so the degrees of freedom is 4. The significance level is 0.05. And the critical R value is 0.83. So let's go ahead and draw that. We will draw the distribution like this in this example. Here is the distribution. We still have a 0 in the middle, but the range is from 0 to 1. So let's put the 1 way out here and the -1 way down here. We were looking for a cutoff point that looks like this. So here would be our cutoff point of 0.83. You can estimate where that would be. That's probably a little too close to the 0 in my estimate, but that's okay, as long as we mark our score properly. And then we can plot in our sample score, which was 0.55. Let me clear up what I'm writing here. R alpha is 0.83, and we'll mark our sample in red, which was 0.55. So let's put that right here. Our sample equals 0.55. And we can see that just like in all our other tests, this falls in the fail region, which is all this other region in this distribution. So our decision has to be fail to reject HO. And if we fail to reject HO, then HO stands. So we says there is not a significant relationship between these variables, but we have to write that in actual words. So let's write, there is no significant relationship between the number of friends an older person has and their physical health. And then we have to put our statistic. We did an R test with 4 degrees of freedom. Whoops, that should say a 4 in the middle there. 4 equals 0.55 NS. And that's the end of the problem.